Alright, let's talk about the find bottom left tree value. So you are given a root of a binary tree, so you have to return the leftmost value in the last row. So this is pretty straightforward. So what we can do is, well, we can just keep going left. If you see there's a left children, just keep going left, right? And then I'm going to talk about two solutions. One is DFS, the other one is BFS. So DFS represent what? Depth first serve, right? And then I'm gonna need a helper function, which is what? Which is going to be a recursion, right? And then I need what? I need a height, so which is depth, right? And then what I will do is, well, I will have a current height, the current result for the height, and also the result, right? I can just initialize it to 0 and also the result to 0, right? And then I will just pass in my root and then current height. I'm going to pass in 1 because if there's only one value in the tree, right? I need to get updated, right? If I say if this is 1 for height, I cannot get updated. So this is how it is, right? I will return result. So this is pretty straightforward. So what's the best case for the recursion function? So if the height is less than the current height, so which is depth, right? If this is less than, then I need to get updated to equal to depth, right? And I need to reset the value, the current tree node to root of that, right? So if you see the first one on the left, right? Because I will definitely keep traversing, going from left to right, right? And so if I see the new value, the new height in the tree, I will just initialize it. I will reinitialize it for sure, right? So I don't have to worry about which one is going to be the first, which one is going to be the last. So if I see the first one in the tree, then I will just get updated. Okay. So root out left, so I will just keep traversing the left value, and then for the next level iteration, I will just get update my depth plus 1, right? And it's actually going to be the same thing for the right. So this is it. So this is going to be pretty much the solution for DFS. And let me wait, line 20 is what? Line 20 is here. Okay, forgot the semicolon right here. And this is supposed to be 0. And then this is what? Root line 30. And this is supposed to be if this is not. Sorry for the mistake, whatever. Alright, so let me submit. Alright, so let's talk about time and space. For the time, you do have to traverse every single one of the nodes in the tree, right? So it's all of them. And for the space, this is like constant for sure, right? So this is all of 1 for the space, all of n for the time. And let me write about the BFS. BFS represents breadth search. So I'm going to use the linked list, and I'm traversing every single iteration, every single level in the tree. And then if I see there's a value inside my next iteration, right, I will just get updated. And then if I have another next, then I will just keep updated, right? So this is pretty straightforward. And if you don't understand DFS, right, you can just follow along the BFS, right? So I'm gonna have a result value and return result. And I need a queue, right? So you can use linked list, right? Q equal to new linked list. And then queue the offer. And I'm passing the root, right? The first one, right? And then I'm gonna say wow. So if you understand this, let me just do this. And then keep going. So while queue is not empty, I'll just keep traversing. I need to know my current iteration, current level node. So I will secure that size. So before I traverse, right? So I will traverse the iteration, the current level, right? So I will traverse the level for what? So if I'm right here, right, I will add the node left, node right to the queue on the next iteration, right? But for this current iteration, this is what the only one value, right? So I will just update this. But if I have this one, then I will just update this one, right? And so I would say what? The result equal to q.pick first dot val, right? So I'm pushing the tree node into the queue, the linked list. So I would say q.pick first val, right? So this is pretty straightforward. I would say tree node. I would say equal to what? Q.remove. So I will pull out the first one in the queue, and what? If the node.left is not null, I will definitely add node.left into the queue. Exactly going to be the same thing on the right. Q.offer, node.right. And this is the solution, so let me run the case. Alright, so let's talk about time is space for DFS. So for the time, it's going to be the same idea. You have to traverse every single one of it, right? So it's all of them. And then for the space, you have to push every single one of it into the queue, right? So the worst case, all of them, right? You push every single one of it into the queue. And this is the solution, and I will see you next time. Bye.